The table below shows the rates of births, marriages and deaths in Ireland from 1990 to 2010. The rates are per 10,000 of the estimated population. So, for example, in the year 1990, there was 151 births per 10,000. There was 51 marriages per 10,000, and there was 90 deaths per 10,000. A. Complete the back-to-back stem and leaf plot below to show the marriage rate and death rate in Ireland during the period covered in the table above. So let's start with deaths. So I'm going to do this stem and leaf unordered, and then in the next slide I'll show you the ordered stem and leaf. So let's start off with 90. So this 9 here represents the 90, so I'm going to put a 0 here. And then very important, I'm going to tick off that I've used 90. Because otherwise, if we don't tick them as we use them, we might forget one or use one twice. So next we have 89. So put a 9 here after the 8. Tick off the 89. Then 87. So put a 7 beside the 8. Tick off the 87. Then 90. A 0. And tick off the 90. 86. A 6 and tick off the 86. 90. A 0, tick off the 90. 87. A 7, tick off the 87. 86. A 6, tick off the 86. 85. A 5, tick off the 85. 87. A 7, tick off the 87. 83. A 3, tick off the 83. 79. A 9, tick off the 79. 76. Tick off the 76. 73. 71. 68. So the 8 now goes beside the 6. 67. 64. 63. 63. And 61. So remember, for stem and leaf, the stem is in the middle. So 4, 5, 6, 7, 8, 9 stands for the 40s, 50s, 60s, 70s, 80s and 90s. And what I've done here is I've written them out unordered. And I ticked off each number, each data value as I used it. Now I'm going to do the left-hand side of the stem and leaf. So now we have the marriages. So we start off with 51. So I put a 1 to the left of the 5, then 49. And I should have ticked off the 51. I put a 9 to the left of the 4, tick off the 49, 47. Tick off the 47, 47 again. Tick off the 47, 46. Tick off the 46, 43. Tick off the 43, 45. Tick off the 45, 43. Tick off the 43, 45. Tick off the 45, 50. So the 0 now goes to the left of the 5 because we're in the 50s. 51. Tick off the 51, 50. Tick off the 50, 52. Tick off the 52, 51. Tick off the 51, 52. Tick off the 52, 52 again. Tick off the 52, 52 again. Tick off the 52, 52 again. See, this is why it's a good idea to tick them off as you use them, because you could easily lose count of how many 52s we had there. Then 50. Tick off the 50, 48. Tick off the 48 and 46. And tick off the 46. So here we have our unordered stem and leaf. Now we have to order them. So we'll draw the same stem again, the 4, 5, 6, 7, 8, 9. We'll have death rate on the right, marriage rate on the left. And then we can start off with death rate. So this needs to be ordered. So the smallest number is 1. So 1 will go here. Then we have 3 and 3. Then 4, 7 and 8. And we repeat this process for the rest of the right hand side. So the lower numbers are on the left, and the numbers get larger as we move outwards. Now for the left-hand side of the stem and leaf, the lower numbers have to be beside the stem, and they get larger as we move to the left. So here we have our ordered stem and leaf diagram. So notice here beside the 6, so these are the 60s. So this 1 here represents 61. This 3 here represents 63. So we've got 1, 3, 3, 4, 7, 8. So notice that the lower numbers are beside the stem, and the numbers get bigger as we move outwards. And then on the left-hand side for the marriage rate, so this 3 here represents 43. This 3 represents 43, this 5 represents 45, and so on. So again, the lower numbers are beside the stem, and they get bigger as we move outwards. And don't forget to include a key. So you can pick whatever key you want. So this 6-1 can be taken from here, so 6-1, and it represents 61. But you can pick whatever numbers you want, but do include a key because that will be worth a full mark. B. State one difference that can be observed between the distributions of marriage rate and death rate in your plot. So you have to have a look at your stem and leaf diagram that you just created, and you need to state a difference in the distributions of the data. So the marriage rates range from 43 to 52. So marriage rates range from 43, that 3 there represents 43, that's the lowest value, to 52, that 2 there represents 52. So they range from 43 to 52. And they are grouped in the top of the plot. We can see that they are at the top. And all of the values are at the top. They're in the 40s and 50s. The death rate ranges from 61 to 90. So that 1 there represents 61, and that 0 there represents 90. And they are grouped in the bottom of the plot. We can see that most of the values are at the bottom, so there's no 40s or 50s. C. Find the median and interquartile range of the yearly marriage rates in Ireland from 1990 to 2010. So again, we're going to use our stem and leaf plot. So we're only interested in marriage, so we're only interested on the left-hand side. Okay, so to get the median from a stem and leaf plot, what you do is you count up the number of values. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So there's 21 in total. 21 in total. Okay, so to find the median, so median means middle value or the halfway mark. So we're going to divide 21 by 2. So in order to get the median, you divide by 2. And half of 21 is 10.5. Now 10.5 is not the median, and this is a common mistake. There are 21 values in total, but 21 was not part of our data. In fact, we can see we have the 40s, 50s, 60s, 70s, 80s and 90s. We don't have any 20s whatsoever. It starts at 40s, so there's no 21 value. So we take the number of values, the amount of values, there's 21 of them, and for the median we divide by 2, and half of 21 is 10.5. Now, if you get a decimal, you round up, so the next value after 10.5 is 11, and the 11th value is going to be the median. The 11th value. It does not mean 11 is the median, it means the 11th value. So we start at the lowest value, which is 43. So this 3 here is the lowest value. And we can see that our numbers are getting bigger as we move to the left. So we have to start at 43 and move to the left and count until we get to the 11th value. So I'll just zoom in on that a bit. So 43 is the first one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this 0 here is the median, but remember that 0 represents 50. So the median is 50. So we get a median of 50. Now, if we had divided by 2, let's say we had 20. Let's say we had 20 values in total. Let's say we had 20 values here, 20 data values, and half of 20 is 10. That does not mean that the 10th value is the median. If you divide your number of values by 2 and you get a whole number, so you don't get a decimal like we did, you actually get a whole number, then you take that value and the next value, you add them together and you divide by 2. So let's say there had been 20 values, not 21. 20 divided by 2 would be 10, not 10.5. And since 10 is a whole number, you would take the average of the 10th and 11th value. So you'd find the 10th value in your list, and you'd find the 11th value in your list, which would be right next to it, and you'd add them together and divide by 2, and that would give you the median. Okay, so now we want to find the interquartile range. So again, we go back to the fact that we have 21 values in total. And interquartile range, the key word there is quartile. So we're going to get a quarter of 21, and we're also going to get 3/4 of 21. So quartile is the key part in that phrase. So interquartile, so think quarters. So we're going to multiply 21 by a quarter, and a quarter multiplied by 21, or a quarter of 21, is 5.25. Now 5.25 is not the lower quartile. LQ stands for lower quartile. 5.25 is a decimal, so 5.25 is a decimal, and just like up here with the median, when we got a decimal we round it up. And even though you might be thinking, well, 5.25 is closer to 5 than 6, when we are dealing with medians and interquartile ranges in stem and leaf diagrams, we always round up. It's the exception. So 5.25 we round up to 6. 6 is not the answer. 6 is not the lower quartile. The 6th value is the lower quartile. So again, we start at the lowest value, which is 43. That's the first value, and we move to the left because the numbers are getting bigger as we move to the left, and we want the 6th value. So 1, 2, 3, 4, 5, 6. Now again, 6 is not the answer. 46 is the answer. So the lower quartile is 46. So 46 is the lower quartile, LQ. Next, we want to get 3/4 of 21. This will give us the upper quartile. So 3/4 of 21 is 3/4 multiplied by 21, and that gives us 15.75. So again, just like here and here, we round up. So whenever we're dealing with medians or interquartile ranges, if we get a decimal, we round up. So 15.75 rounds up to 16. So the 16th value is going to be the upper quartile. UQ stands for upper quartile. 16 is not the answer. The 16th value is. So again, we start at the lowest value, which is 43. And we move to the left because the numbers are getting bigger as we move to the left. Now, if we were dealing with the right-hand side, we would be moving to the right. So we're at 43. So this is the first value. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10... 11, 12, 13, 14, 15, 16. So this is the 16th value. This is the upper quartile. And the answer is not 1, it's 51. So 51 is the upper quartile. So 46 is the lower quartile, LQ, 46. And 51 is the upper quartile, UQ, 51. UQ upper quartile. And then the difference between 46 and 51, so 51 take away 46 is 5. So the lower quartile is 46, the upper quartile is 51, and the interquartile range is 5, and that's what you're asked to do. So in order to find the median, you take the number, the total number that you have, in this case is 21, you divide it by 2 to get the median. And for the interquartile range, really what you're doing here, multiplying by a quarter, is the same thing as dividing by 4. So you could have done 21 divided by 4 if you wanted here. And multiplying by 3/4 is the same thing as dividing by 4 and multiplying by 3. So you could have done that as well. Now, just like with the median, remember I said if we had divided by 2 and got a whole number here, we would have taken that number and the next one, added them together and divided by 2. It's the same now for the lower quartile and the upper quartile. If we hadn't gotten a decimal here, let's say instead of 5.25 we got 5, then we would have taken the 5th and 6th value, added them together and divided by 2. And likewise with the upper quartile, if instead of 15.75, instead of a decimal, we had got a whole number, let's say 15, we would have taken the 15th and 16th value, added them together and divided by 2. D, part 1. Find the mean of the debt rate in Ireland from 1990 to 2010. Give your answer correct to one decimal place. So we're interested in the debt rate, which is the right-hand side. So for the mean, and again we're interested in the death rate, so we're only focusing on this part. We're going to add together each of these values, and then we're going to divide by 21, because remember there's 21 values in total. So this one here represents 61. So you can put it straight into the calculator. 61 plus 63 plus 63 plus 64 plus 67 plus 68 plus 71 plus 73 plus 76 plus 79 plus 83 plus 85 plus 86 plus 86 plus 87 plus 87 plus 87 plus 89 plus 90 plus 90 plus 90, and you should get 1,645. And divide that by 21 because there's 21 values in total for the death rate. And rounding to one decimal place, we get 78.3. Part 2. The standard deviation of the death rates in the table over is 10.3. List all of the death rates that are within one standard deviation of the mean. So the standard deviation has been worked out for us. We don't have to work it out in this particular question. It works out to be 10.3. But very, very important that you are expected to know how to work out standard deviation. And the quickest way to do it is using the calculator. So there is a video in LCOL statistics playlist on how to calculate standard deviation using a calculator. Okay, so 10.3 is the standard deviation that's given to us. We worked out that the mean was 78.3. We worked that out in part 1. So this was for the death rate. So what we did was we added all these values together and we divided by 21 because there's 21 of them. And we got 78.3 rounded off to one decimal place. So there's a range of 1 standard deviation about the mean. We're told it in the question, 1 standard deviation. So we take the 78.3, which is the mean, and we subtract 10.3, which is the standard deviation, and that gives us 68. And then we take the mean again, 78.3, and we add 10.3. We add on 1 standard deviation, and that gives us 88.6. So if this had said within 2 standard deviations, we would have multiplied this by 2 and subtracted it from 78. And we would have multiplied this by 2 and added it to 78.3. And if it had said within 3 standard deviations, we would have multiplied this by 3 and subtracted it, or multiplied this by 3 and added it. Anyway, it said within 1 standard deviation, so we subtract 1 10.3, and then we add 10.3, so we get 68, 88.6. So now we have to list all the death rates that are within this range. So we want anything that's 68 or greater. So 61 we won't include, or 63 or 63 or 64 or 67. We will include 68. We will include 71. We will include 73, 76, 79, 83, 85, 86, 86, 87, 87, and 87. And we won't include 89 or the 90s because they're bigger than 88.6. So here they are. They're not in order from smallest to largest because this would have been taken from the original table, but you can write them in order from smallest to largest if you want. So these are the list of death rates that are within 1 standard deviation of the mean. E. In 2010, the number of children born in Ireland was 75,174. Use this number to estimate the total population of Ireland in 2010. So the table below shows the rates of births, marriages and deaths in Ireland from 1990 to 2010. The rates are per 10,000 of the estimated population. So the rates are per 10,000 of the estimated population. So in 2010, there were 75,174 children born. We're going to divide that by 165 because that was the number of births in 2010. Remember, this is per 10,000. So we divide it by 165 and then we multiply that by 10,000. And that gives us 4,556,000. So this is an estimate of the total population in Ireland in 2010. So 4.5 million. Use your answer from E to estimate the number of people who died in Ireland in 2010. So again, remember that our data was all per 10,000 of the estimated population. So in 2010, there was 61 deaths per 10,000. And in the previous question, we worked out that there were 4,556,000. So that was the total population. That was the estimated total population of Ireland in 2010. So we're going to divide this total population by 10,000 and multiply it by the number of deaths per 10,000, which was 61, and we get 27,791. So this is an estimate of the number of people who died in Ireland in 2010, 27,791. Part G. More children were born in Ireland in 1990 than in 2000. Give a reason based on the data why this statement is not necessarily true. So this statement is not necessarily true because the birth rates given are per 10,000 of the population. If the population in 2000 was greater than in 1990, more children could have been born in 2000 than in 1990, even though the birth rate in 2000 was lower, because it depends on the total population. H. Find the ratio birth rate to death rate for the 2 years 1990 and 2010. Based on your answers for the 2 years, what would you predict about the population of Ireland in future years? Give a reason for your answer. So we go back to our table again. So this is the year 1990 and the data for 1990. And this is the year 2010 and the data for 2010. So there was 151 births per 10,000 in 1990. And there was 90 deaths per 10,000 in 1990. So for 1990, the ratio is 150 to 90. In 2010, there was 165 births per 10,000. And in 2010, there was 61 deaths per 10,000. So for 2010, the ratio is 165 to 61. Prediction. The population of the country is expected to increase. And the reason is, the increase in the ratio from 1990 to 2010 suggests that more children are being born for each person that dies. I. The birth rate and death rate over the 21 years are plotted against each other in the scatter plot below. The correlation coefficient between the two sets of data is minus 0.85. Now, correlation can only ever be between -1 and 1. Describe the relationship between the two sets of data and suggest a reason why this might be the case. So the relationship is there is strong negative correlation. So there's strong correlation because this number, minus 0.85, is quite close to -1. And we can also see that these dots are quite close to a line. We could draw in a line of best fit. And we can see that those dots are all quite close to that line of best fit. So the correlation is strong, first of all. If this number was closer to, let's say, minus 0.5, we would say it's moderate correlation, and these dots would be further apart. And if this number was very close to minus 0.1 or minus 0.2, we would say there's weak correlation. And these dots would be very, very, very far apart, but they would still form a line. And we say it's negative correlation because this is a minus and because this line is going downhill. So if this had been a plus and the dots were going uphill, it would be positive correlation. So with the increasing birth rate, the population is getting younger and the death rate is declining. The death rate is going down.